Is it better? Okay. All right, I'll keep it quick. This is a quote by Microsoft CEO Satya Nadella. It basically talks about coming in the near future, computing will be everywhere. That means in your microwave, that means in your computer, that means on your mobile phone. We need to start thinking in the context that the entire world is a singular computer. And that's where the world is going. And that is Microsoft vision. That's Microsoft vision. I don't believe in miracles, and what he's saying is actually a miracle. The problem with our industry today is that basically there is business model changes that need to happen, as well as technological advances that need to happen to make what Microsoft's saying come true. And what we have is we believe we solved the fundamental technology problem, and we have also resolved the business model problem, and I'll show you how that happens. Okay, so our project and our product is about cloud computing, and as you guys know, cloud computing is a huge space. So by 2022, it will be a $350 billion annual revenue market with a 40% margin, and 80% of that money, 80% of that profit goes to two companies, Microsoft and Amazon. Now, with that being said, the entire cloud computing technology stack actually is very, very old. So what Microsoft and Amazon got stuck with is they built this stack on 20-year-old technology, and they kept building on top of it. So this is why you see all these layers. So to get to today's cloud computing, to execute your application, you got to install the hardware, you got to install the networking, you got to install a hypervisor like VMware, you have to install Windows or Linux, you put Kubernetes and Docker on it, and then you put your application on it. All that costs a lot of money, and all of that is very insecure, and all of that is very inefficient. Now think about that. With all of these problems, Amazon and Microsoft's cloud revenue is still 40% margin business. There's something wrong with that. Just one slide about security. So today's security model, when we're securing the cloud, they secure from a perimeter, and then they add another layer with it, and add another layer with it. So what that is a problem in terms of actually securing the pillar of what the company really wants to secure, which is the application data and the application execution of the code itself, which as many of you seen in terms of data breaches around the world, no matter how many security products you buy right now, that is still a problem. Last thing about what's wrong today, the world is moving to 5G, to augmented reality, virtual reality. All of those things require very, very fast transmission times. That is actually limited by the speed of light. Light only travels 22,000 kilometers a second. So take a very easy example of what's wrong with the cloud today. If you use a mobile phone to call an Uber in Kenya, the application has to travel to Johannesburg, which is the nearest Amazon data center, because Uber lives on Amazon. It does an 8,200 kilometer round trip. Uber pays a lot of money for that. The users experience the slowness, and it's just not a very good experience. And since the world is wanting to move closer, we need to have technology models, technology stacks, and business models to make that happen. And today, unfortunately, with Amazon and Microsoft in charge, that is not happening. They're still bringing users back into the centralized cloud model with their new offerings like Azure IoT, which brings you back and locks you back into Microsoft Azure. This is today's Amazon data center map. All the red are areas where there's no coverage. The way that Amazon builds data centers is they throw a huge amount of money at it and build a very large capacity data center. It costs about $4 billion to build there. That's not going to work in the new world. You can't build a $4 billion data center in Egypt and expect to make money back from that. So, because of the coverage issue, the security issue, here's two very interesting facts. An enterprise needs to pay 4.8 different cloud providers to run their application. They buy 26 security products to try to secure it. In fact, the security products now are becoming such an issue that they become security issues themselves. And these two, the tools and security products, they're all $50 billion market industries. just to secure and orchestrate the cloud. But really, what does companies and enterprises really want? They just want to run their app. That's it. Developers just want to put their app on there and it goes around the world, and they don't want all this stuff. And today, that just doesn't exist right now. One last slide about what's wrong is the business model. If you look at the right, that's $350 billion. On the left are the telephone companies, the mobile carriers, the service providers. They make absolutely zero. That's ridiculous if you think about it. It's their users, they're paying for the transit to go to Amazon, but they just don't have the global capacity and capabilities because all of these carriers are regional. They don't have the technology team, they don't have the resources to go around the world. But that's what apps developers want. They want to put their app on Amazon. It's propagated around the world. So unfortunately, the telcos and the carriers cannot capitalize on their own users when they access the cloud, which is kind of funny. So our solution to this is called the Trustack fabric. It's actually a pretty simple answer to a very complicated problem. We built a distributed mesh computer that essentially makes nodes and different servers compete with one another for the job. So technically, it's actually, if you think about Slack, it's actually a chat room. So if you put all your servers in a chat room and you advertise a job, because it's limited by the speed of light, the first one that received the message and got the job probably is the fastest one. That's just logic, right? So, and I'll explain that a little bit later. But what's interesting about this is it's simple, but it's also very smart. It's done by a distributed ledger. It's actually currently sitting on EOS, which is a platform that my friend Brendan Bloomer built a couple of years ago. But it's actually blockchain agnostic. We do not need a blockchain to be running on this. We're just using EOS because we didn't want to do the extra work. But we're more than happy to create another blockchain, but I think it's not really necessary. An application is called Procedure on a platform. This is the first distributed ledger technology that is real time. There is no log time. The reason we can do this is because we use trusted hardware. And we use something called zero-knowledge proof to process the execution, which means that even if your hardware is hacked, your answer is still correct. And that is done by continuously, maybe every 15 to 20 milliseconds, sending some random calculation. If they got it wrong, we'll take them out of the network. So we send it first, and then we post it onto the ledger later. This is the logic of how that goes. So the client hits a proxy node within our mesh. It goes to the API chat room. First guy that gets the job raises his hand. Oh, I'm processing it. Okay. It returns the result and goes back to the client. This is very interesting because a proxy node and a procedure node is actually the same computer or the same server, except for this guy on top is usually the closest. Which means that you're always going to get the closest servers executing your application. I will skip the security part because we're out of time. If you were I'm more than happy to share that with you. This is the reputation system. Again, we've removed the need to build redundancy and additional data centers for high availability with a reputation system. And that is because if you're doing multiple calculations within a mesh, you're actually redundant already. So, I mean, this is really technical, so I'll skip this later. This is one additional use case I would like to highlight. This is the application routing intelligence that we have. This is pending patent. So what this is currently, if you want to train your AI model or process a GPU heavy task, you're going to Amazon EC2 and you're provisioning an EC2 instance. You have to install something. You have to install your OS. You have to put your stack on it. All that is work. This, you don't need to work. So if your node, your server has a GPU or AI hardware on it, you just say, I have it. And within this chat channel, if there is a program that needs to be executed that says I need AI, it will get the job. This saves a tremendous amount of time, and this is something Amazon doesn't have. The other thing that we're going to be able to do with this platform is called good, better, best model. And we say, well, if you're using AI, by the way, AI and machine learning is very expensive on Amazon right now. If you don't care if you get your result back tomorrow or in 30 minutes, we can schedule you to have that done using idle time on the network. It might only cost 20 cents out of $1 that you would have spent on Amazon. Okay, I'm a realistic guy. I know I can't compete with Amazon, but this is a very interesting use case that works together with Amazon. You have Amazon data centers in Europe, and if you're Uber or you're Netflix, you want to extend your reach. We have Trustack nodes that are very close to the user. So this model is maybe 40% of Uber's traffic will be on Amazon, but the other 60% is actually very close and within Trustack. This is an interesting one for China. A lot of companies don't trust Alibaba. They don't trust China Telecom. They don't trust these Chinese carriers because the governments might be able to hack, right? So what we've done is we've been able to use our $0 proof technology to mask and protect your data privacy and execution privacy, which means that if you're installing or you're running your app globally and you have to use something in China, and it has to be in China, you install this on top of Aliyun, and they can't see anything anymore. I'll skip that. So we believe with how easy this is to maintain and orchestrate, you just plug in the equipment and then it goes, and you don't have to do anything about it. If it fails, you take it out. There's no real need for orchestration or very expensive cloud engineers. So we believe we can get this to service providers like SK Telecom, like Docomo, like SoftBank. And I'll tell you why that's really cool. This is the business plan. What we want to do is build a world distributed cloud service. And this will actually be in partnership with carriers and service providers around the world. And they'll aggregate all of their, we'll aggregate the entire platform to create a super cloud that has more compute power and footprint than Amazon, Google, and Microsoft combined. And to do this, actually, it doesn't cost much money. And I'll tell you why. First of all, the team. So we have some very interesting people that I'm not showing on the team because we are in stealth. I am one of the original members of F5 Networks. We are an application performance company that have literally built the entire internet. I've been personally involved in the scaling and the building of the platform with F5 technology for Facebook, for Twitter, for Azure, for Apple iCloud, iTunes, Bank of America, SK Telecom. Mostly all the companies, I actually know what their infrastructure is like because I've done work on them. But two of my friends have done some work with Microsoft Azure. So one of them led the security design for Office 365. The other guy built the SDN stack for Microsoft Cloud. What we want to do is a holistic ecosystem approach. We want to build a world public cloud. We want to open source our software to give it to enterprises and service providers so they can use it. That will drive the adoption for the public cloud. We also want to sell service providers bare metal, cheap hardware to run our platform. And we want to work with SaaS companies like Salesforce, like Splunk, like Oracle to put their software on our stack so developers can call the application directly. And we'll give them a percent, maybe like we'll take 20% from an execution for our Oracle application. Okay? Again, I talked about the partnerships with the service providers. So our goal is probably to build 8 to 10 ourselves in terms of data centers, and we'll expand the reach with telephone carriers. Why is this interesting? Because once we reach critical mass with this model, it fundamentally redistributes how cloud revenue is recognized and who that money goes to. Currently, 80% of that $300 billion goes to Amazon and Google. In this model, it goes back to the carrier. we'll just be an Uber or Airbnb for cloud. We'll take 30%. But this allows one very, very interesting case for the carriers. It enables them to finally monetize their users' cloud consumption, which they have not been able to do. This is an interesting use case. Well, we are talking to one carrier in Japan. I can't tell you which one. You have to sign an NDA for that. But essentially, instead of buying 4.8 cloud providers, it's because if your user is in Docomo, right, you're going to Docomo. You're not going to another cloud. It works much better in terms of cost because you're only paying for execution if it actually happened. You don't need to pay for 4.8 cloud providers to be on standby waiting for something to happen. You pay for the execution, that's it. So we circle back to the Kenya problem. So instead of going to the Johannesburg data center for Amazon, for Uber, in this model, we throw bare metal and cheap hardware into Africa and to the carriers, and now the execution is occurring here. I'll skip the market where we're going after. If you want to know more about this, I can explain to you later under an NDA. Again, I'll skip the other three. We just talked about the public cloud. I'm out of time. This is our revenue targets. I'm a very realistic guy, and this is a very conservative estimate in terms of how much revenue we'll get. Now, mind you that it's very easy to get this because our market is 300 billion. I don't need to move the needle that much. I just need to get 1% traffic switch to Trustack to get this. That's it. So with our funding at about 40 to 50 million, we're going to be able to get by 2021-ish, $55 to $60 million run rate. That is very, very conservative, and we have models and studies for this. Okay, and I'm gonna skip this. We're not doing ICO. It's funny that we have a very solid use case for blockchain, but the ICO model does not work for us because telephone carriers and application developers don't want to pay crypto. So we're offering a security token. We're in the middle of raising our Series A right now in seed, which I'm also crowdfunding, and that's being nearly oversubscribed. So if you're interested, please talk to me. So in terms of the token offering, we're going to be doing that in 2019. We're going to be forecasting our valuation to be about 120 million for that round. And that's going to be a Series D. And with the SEC, it's going to be registered out of the US, and it's going to be completely legal. So that's why, and this is what we're spending the money with. Now the key one is actually on the right, the marketing. Essentially, what we like to do is give away credits to app developers to move to our platform. So it's much like Uber, where they have kind of subsidized the drivers for a couple of years to jumpstart the adoption. This is the model we're going with. This is mostly after the first round of funding. The second round of funding is going to be mostly loans and service credits. That's what we worked out for the model for funding. And we're looking at, I mean, the product's already done, so we're looking at within half a year, we're going to be getting about 600 beta participants on this, and about 25 enterprise POCs and 3 to 4 different service providers on. So once that's done, that's when we start the real expansion, once we close the 2019 SDO. So that's really it. Sorry I talked very fast, but if you have any questions, yeah, this is the time. Any questions?